We are in a situation where we are actually required to look at our ventilation systems and where we encourage retrofits. This costs money, but we can also achieve a lot of savings if we do the retrofits correctly and if we make use of the technology which is available, readily available in the market, which we have heard today from our various speakers. I would like to ask Jesper the same question. So if you think about the cost involved in the retrofits, what is the cost and use balance if we start retrofit projects now?
Well, of course, I think you mentioned the COVID-19 situation, Marcus, and one of the issues there is, of course, for example, and technology with air recirculation inside the building is really, I think, something we would not see in the future. We would see dedicated outdoor air systems coming into force, meaning that you are not allowed to recirculate the air, but need to take all the air going into the building directly from the outside, meaning that you also have then to cool, filter, and air condition a much higher air volume than what you did in the past. And of course, suddenly that would bring a lot of attention to the total system efficiency. So how much energy do you actually need to spend to move the air inside the buildings, through the filters, through the heat exchangers, through the coils, and through the fans? And therefore, what we expect is that there will be a very, very increased focus on total system efficiency, looking for the most optimal air handling or air movement solutions, which would give you the highest total efficiency. And that's where we are focusing on these state-of-the-art new technologies, which are reaching total system efficiency of up to 85%. Which is available in the market. I showed one in the air handling unit in my presentation.
Thank you, Jesper. Saad, I see that you want to add to that.
Yeah, I mean, one question I managed to probably not answer properly last time, I think I was overlooked, is that if the belt-driven is still in demand. Again, I could only talk about Clima Uno perspective. There is a lot of demand for it, yes. Is it the best solution? Again, it's subjective. I mean, the audience here and the panelists here could have a different opinion, but I think obviously the belt-driven is cost-effective for customers. However, it isn't the best solution from energy conservation, and as well noise-wise, it's obviously not the best solution. So let me answer that question. Is still there, but I think the direct drive is much better option for customers and end users. Going back to the retrofit, again, I kind of agree with my colleague Jesper, who actually gave all the answers that I would give him. I could only add that the growth in that particular section of the market is growing, as we could see, because of the tight, obviously, capex that people are looking at different options. We have great options here in Clima Uno, and we do see that we are thrown with different questions and difficult challenges to actually help the AHUs perform better, give a better acoustic kind of a response to problems we see, and also give obviously comfort into the occupancy. Obviously, we use Cohen's sometimes methodologies, and we use the others that are here on this panel, their solutions.
Thanks, Saad. Lubna, if you join me as well, I would have a question to you. Saad said it, the belt-driven fans being very cost-effective. That means is cheap solution. But when we talk about improving indoor air quality, and we are talking about now fixing things which we have not taken care of in the years before, we should perhaps also give a message to the market that to fix something later on is perhaps more expensive than investing right up front into a proper air handling unit system. Can you agree to that?
Yeah, sure. Bell-driven fans is being used for the air handling units for many years, and now yes, EC fans is becoming a trend because there are various advantages. Because when we come across with the clients and consultants, they have like especially for the critical areas like hospitals or data centers or the isolation rooms and all. You cannot afford to have the fan stopping at any moment of time. So EC fans is quite a good solution because you can have like an array of fans, a number of fans, and in case one fan fails, the other fans will ramp up to deliver the same airflow. So there is no kind of stopping of the operation. The unit is running continuously. This is one of the thing, and also in terms of retrofit, EC fans are quite compact compared to the bell-driven fans, and they can be easily accommodated inside the existing air handling unit. So, this is another advantage of it. And specifically for the power consumption, let's say for the retrofit jobs, it's designed on particular, the power consumption. But when you have EC fans, the power consumption reduces because that's one of the advantage because it can vary the airflow based on the requirement. So it can reduce the power in the existing buildings. Thank you.
Thank you. I have a question from our audience to Paolo. If you could join me, please.
Yeah.
One person asked, is it not possible to have the adiabatic cooling at the supply air site?
Yeah, I mean, depends on the application. The idea is to humidify the air that is not going inside the building, because otherwise, in a way, you are going to modify the absolute humidity. So it's important to work with the airflow that you are like, we call it like process air, because it's something that we are using, you are modifying for a different purpose, for cooling down the temperature of the supply air. For example, in the data center, we humidify the outdoor air because it's the one that then we exhaust away from the heat exchanger. Instead, in the hospital, we humidify the extract air to have the supply air with the absolute humidity that we need without modifying it. Because this is an indirect evaporative cooling, so that means that we are going to decrease the temperature of the supply air indirectly. So through the heat exchanger that creates like a barrier and can avoid any type of cross contamination and even like a variation of absolute humidity of the supply air.
Okay, and the same person also asked, how do you calculate the water spray quantity?
You mean quality or quantity?
The quantity of water you have to add to the system that it performs.
Yeah, we have done several tests at university that helped us to develop the model. Then also the model has been validated and has been then proved by our customers. And we have seen through the model that, of course, the absorption rate is has got a rate, has got a value, and of course we have some water that is going inside the heat exchanger. It's going to be wasted, but of course it depends on the application. The only thing is that's important, if you want to recirculate the water, you can, because the heat exchanger can afford this without any problem because of the resistance, but you have to take care of the characteristics of the water. So with the model, we can evaluate the performance, the quantity of the water that is needed to reach the performance requested.
Okay, thank you. I have a question to Lubna regarding the UVGI component. In case you have more than one cooling coil, where do you place the UVGI?
As I mentioned in my presentation, as per ASHRAE, it is recommended to have the UV lamps after the cooling coil. So because when you place the UV lamps after the coil, you're disinfecting the coil as well as the drain pan. Actually, drain pan is very important, the section, because it has all the water accumulated and it can increases the chances of, growing fungus and mold. So it's, even if you have 2 coils, you have to place a UV lamp after the second coil.
And how does UVC reduce the pressure drop across the coil?
UVC 254 nanometer, as mentioned, because there is, this is again by ASHRAE. They found that at UVC 254 nanometer, it has the optimal strength to disinfect any fungi, mold, and viruses. So this wavelength of 254 nanometer helps to disinfect any mold, any fungus growth on the cooling coil.
Okay. Thank you, Lubna. I have one for Cohen. Mohammed Hamid wants to know if you have done a CFD analysis on EC motors to see the airflow versus the belt-driven motors. I guess you did.
Sorry, a CFD analysis?
A CFD analysis of the airflow EC versus belt-driven fan. As you have showed in your slide, the comparison how the air is distributed over the cooling coil if you have a belt-driven fan and compared to a fan wall.
Yeah. So the difference, what we see is that, of course, when you take the AC belt-driven fan, you really have a sort of an outlet where the motor is the fan basically is placed, and with the EC fan, the EC array at least, we are using the complete inner dimensions, or at least as much as possible of the complete inner dimensions of the AHU, and therefore we can also get more airflow and also less pressure through basically through the ducting.
And I guess this is also that you use the higher servo, a bigger surface of the cooling coil altogether, because the air is
correct. Yes, correct.
Spread more evenly. Yeah. Okay.
Yeah. So what we sometimes see with retrofit, of course, is that the ducting, the opening for the ducting start is very small, and sometimes indeed we need to make that a bit bigger, because then we get the airflow even better and the noise even lower through the system. But for a lot of times we don't need to change anything, but sometimes we see that we need to get the ducting, or at least the opening, a bit bigger so that we can get less noise and more airflow and less pressure through the system.
What is the approximate downtime to replace an EC fan in the case of a failure?
Do you mean an EC fan?
Yeah.
Yeah. Well, but it's only 4 screws and some wiring. So when the fan comes from supplier or is in stock at the customer, is just shutting down. Make sure you get the old fan out. It's 4 screws and 4 bolts. Take the power off and put the new one back in. Of course, you need to do some ducting. So I would say in 1 hour you can easily replace a fan.
Thank you, Cohen. I have one more for Paolo. Is there any troubles about Legionella when we talk about indirect evaporative cooling?
Of course, we are using water in the system, and of course you have to take care of everything ready to using water and to have some water in a drying pan, with making all the necessary actions to avoid any type of problems regarding the Legionella, or regarding also the other type of problems that belongs to the water characteristics. Depends also if you throw away the water or still keeping the water inside the circuit. Then you have to take care also of this topic.
Okay, thank you, Paolo. I'm seeing what else we have left. Lubna, you want to add something?
Yes, actually, I would like to add something on my previous answer, because when you mentioned dual coil, 2 coils, I referred the coil one above the other. But when you have 2 coils on side by side, like you have first coil and then you have the next coil, then you can place the UV lamps between the two coils because it will disinfect both the coil and the drain fans. Just wanted to add this. Thank you.
Okay, thank you. I have another question. What's the recommended penetration of a UV lamp? Lubna, if you could.
Yes. See, to have a right irradiation for UV, it is important to design the UV lamps at a right intensity. So the UV lamp manufacturers, they are the expert to find out like what dosage or what intensity the UV lamp should be designed. So they should refer to the UV manufacturer.
Right. So then one last question for you, Lubna. What are the special insulation gaskets we use in hygienic handling unit?
Can you repeat the question, please?
What is the special insulation gasket in use in hygienic handling unit?
The gaskets, as I mentioned, it should comply to ISO 848 standard, which I mentioned in my presentation. And it should be made of closed cell material. It should not be an open cell construction, and it should not emit any odors or harmful substances.
Good. I will do one more general feedback round among the panelists, and I would like to ask every one of our speakers now, and also Zakir, please, if you are with us, to switch on your webcams. And we do a last round. For all the remaining questions which we have received from our audience, please be patient. We will distribute your questions to our speakers, and they will have then the opportunity to reply back to you by email. Again, thank you everyone for your presentations. To close this two-part webinar, I would like to give one more the word to you. For a message, what do you recommend to the market? What do you recommend to the people in order of taking care of COVID-19, of maintaining your ventilation system, of approaching retrofits? If I may start with Sad.
Yeah, thank you, first of all, for the audience and for yourself, Marcus, and Eurovent. Great job. My recommendation from a ventilation perspective is to ensure the filters are clean and tidy, ensure that, again, UVC are used if possible. I'd recommend that we continue to maintain the AHUs and all the other products at the recommended manufacturer's timing, and put ASHRAEAs and better FM. So simple message, keep safe.
Thank you, Sad. Lubna?
Sorry. Yeah. For the retrofit and for the COVID-19, specifically, we can hear a lot of UV, in the market. And generally, UV is for the surface disinfection, but it is also used for air disinfection nowadays and can be used inside the air handling units. But it's very difficult to have that much of space in the existing air handling units to accommodate these UV lamps. So generally what is happening is it is better to have these UV lamp inside the duct and designed with the right intensity. And I wish everyone stays safe. Thank you, Eurovent. Thanks again.
Thank you, Lubna. Zakir, what would be your message in regards to retrofits at this time? You are still muted, Zakir.
Yeah, I'm audible now.
Yes.
Yeah, right. Yeah, so it goes without saying, with this COVID-19 condition, the indoor air quality is very important for everyone's safety and hygienic reasons, first of all. And regarding the retrofit, I think I would reiterate what everyone else said. The efficiency of the system is very important. And we need to have a closer look at the entire system on how it works and on monitoring preventive maintenance, like my Danfoss colleague said, is a very crucial part of it to prevent things from happening in the future. And yeah, I would like to say the same message: stay safe and stay indoor maximum.
Thank you very much. Paolo?
Yeah, as anticipated by Saad, and the maintenance from our point of view is really important to guarantee the right functionality of the heat exchanger, especially the rotary heat exchanger that should be installed in the right way, while the plate heat exchanger is more like reliable and can guarantee the tightness between the two flows. Regarding retrofit, we have seen the AC technology could be used, could be something really profitable that can be installed in an easy way inside the handling unit to reduce the running costs without creating any more problem, but just saving money. I have to thank also all of you for giving me and giving us the chance to be part of this great group regarding this webinar. Thank you.
Thank you, Paolo. Jesper.
Yes, also again, thank you for this opportunity, and thanks to the audience. My final comment here is, as I mentioned, a prerequisite for a good and safe indoor climate is that the ventilation and air conditioning systems are actually running. If they go down, they would immediately jeopardize the health of the occupants. There are now new technologies in place which can give and provide early warnings, as we get in many other instances before breakdown. You see the same in your car, that something is about to happen, and you will actually have time to correct it before it happens. When it comes to belt-driven fans, when it comes to air handling units and system efficiency, we do see technologies out there which provide a very, very high total system efficiency comparing to, for example, belt-driven fans, which would typically be around 50% total system efficiency, and now you reach up to 85% with technologies available. So I look out for total system efficiency. That's is going to be very important in the future.
Thank you, Jesper. Cohen?
Yeah, of course, start buying EC fans. That would be my general message, but that's not it. We see the market changing, and with that, for companies who provide EC technology, that is wonderful, and also for energy savings, it's wonderful. But it can also be a trap where we see that it is a different technology than the old-fashioned EC technology, and therefore we, as EC manufacturers, we need to train our customers, and we also need to provide as much as info as possible. And with retrofit, I would say it's not only the fan. That it's not just replace a fan and everything works fine. I think it's a combination of replacing a fan, adjusting the controls, and make sure that the installation is done well. Because if you don't do the installation well, you don't use good controls, then it's a waste of money, and it's just replacing something to be replaced. And for me, that doesn't make sense.
Yeah, I would like to add again on this moment a message to everyone: cheap is always more expensive. So cheap solutions should not be, or the price should not be the first factor to look at anything related to a ventilation or air handling or air conditioning system. We've seen that too many times that that ends up in much higher costs on a few years in, with damages to the buildings, damages to the systems, higher replacement costs, bigger maintenance problems, and of course an impact on our health. I have a final question from Mohamed Safer, who is asking, is humidity control really a criteria to control COVID-19? And I would like to take this question to myself. I have really followed all the scientific studies on that matter over the past few months in order to be able to guide and prepare industry recommendations. I haven't seen a clear picture what the humidity does to the infectiousness of the virus itself. However, everyone in the industry is in agreement that a relative humidity indoors between 40 and 60% provides you the most comfortable environment, and that is also enormously important for our own respiratory system. So if you go if you have experienced a longer flight on an airplane, and specifically with the older planes where the relative humidity is extremely low, you have issues with your breathing. You have an itchier throat. The ideal range of indoor humidity is recommended by ASHRAE and by other organizations to be between 40 and 60%. That protects our respiratory system in the best way. And by that, it is of real essence that we monitor the indoor air quality, that we do our best to stay within this range, which gives us most comfort and also protects our own immune system the most. Again, we will share the remaining questions, or we will share all the questions we received with our speakers. They have the opportunity to then reply to you personally by email. I'm sorry that the time is always limited on a webinar. We cannot always cover everything. The handouts of both webinars from last week and from today will be available for download in a few days from our website as usual. And we also have recorded these webinars, and we are working on it to break it apart to make all these presentations available as a short video also in a few days. Hopefully, once that is available, we will notify on our LinkedIn site. Please don't forget to follow us on LinkedIn so that you always keep up to date of what's going on. I come to the end of this event. I would like to thank again all of our speakers. Thanks Cohen, thanks Saad, thanks Jesper, Lubna, Paolo, and Zakir / Frank. Thank you very much for being with us today and for having taken the time and the efforts to prepare the presentation and yourself.